Okay, hello everyone. This is my 5th period coming at you with percent yield and limiting reactants. Subscribe, like, comment to my YouTube channel. So we have done 3-step problems. We're pretty familiar by now with how to use this T-chart. So now we're going to apply 2 concepts to it, and that is going to be called limiting reactant and percent yield, which we have studied during our s'mores lab. So during our s'mores lab, an example of a limiting reactant would be like if I had 100 graham crackers, right? And then I only have 2 marshmallows. Okay, 100 graham crackers, 2 marshmallows. How many s'mores can I actually make? I can only make 2. So I have a lot of leftovers of what? Graham crackers. So in this case, my limiting reactant is going to be my marshmallows. My excess reactant is going to be my graham crackers, which is also known as my leftovers. And also Gus is over there working up her little nest. So I decided to use the same equation from your other sheet. So that gives you so much, less work to do. So let's go ahead and fill in our molar mass. So C4H10, what is the molar mass of this? 58. O2, what is the molar mass of this? 32. CO2? 44. Awesome, she got it memorized. And then H2O? 18, yes. So these are the molar masses. And on your test, you're going to have to be able to find molar mass very quickly because you got other things to do. So if you're not proficient in this is something to practice. So let's go ahead and write down the definition of limiting reactant. This is going to be the ingredient that is used up first. Ingredient. I'm going to say the ingredient that is used up entirely. Okay. So this ingredient is, and because it's an ingredient, that means it's a reactant. That means it's going to be on the left side of the reaction. Same thing with your excess reactant. And like we said, looking at our excess reactant, what is the word that can be used to describe excess?
A lot.
Starts with an L. Leftovers. Yes. Because we have a lot of it. Therefore, it's our leftovers. Okay, leftovers. Ingredients leftover. So how does that apply to our questions? Our question states for number 1, when I react 10.9 grams of C4H10 with 10.9 grams of O2, how much H2O in grams, I forgot to write that, will be produced in the reaction? So right off the bat, let's just identify what are we given. What are we given? 10.9 what? Of C4H10, but don't we have another given? Yeah, and that's grams of O2. So we're going to have to use both numbers, but separately. We can't use both numbers in one T-chart. We have to separate it into 2 T-charts, which is why you see 2 down here. So what are we trying to find, right? So the H2O, exactly, in grams. So H2O in grams. So basically what you're going to do is you're going to write both ingredients on the top left separately. Okay. And with both of these, you have the same goal. And the same goal is going to be to solve for grams of H2O. So I'll go ahead and write it over here. I'm going to turn off this music. Okay. So from here, are we able to solve for this? Yeah, absolutely. We've had a lot of practice. But we need to find out our why. Why are we doing this? So ultimately, we're going to get a number for both of them. Okay? And the number for both of them is going to be the product of the reaction, so grams of H2O. But the number that is going to hold true is that the smallest number will be your theoretical yield. Theoretical yield. This is what you will theoretically find. Okay? And based on your smallest number, that means you can determine what is your limiting reactant. Your two choices for your limiting reactant is either going to be C4H10 or O2. Okay, so let's go ahead and fill out the chart. So, everybody, looking at this right over here, what are my units? Grams of? Right, we got it. So then on the top, what do we have up here? No, you were right first. 1 mole. C4H10, right. C4H10. So from here, remind yourself, is it going to be mass ratio mass or ratio mass ratio? Mass ratio mass. Just keep saying it. Say it in the middle of the test if you need to. Mass ratio mass. When is our test, everyone, by the way? Next Tuesday. So, y'all got it. We're going to have plenty of practice. So, when we look at C4H10, remind me, what's my molar mass? 58. There you go. 58. And then let's continue. Students tend to hesitate because when they have to get to the next step, they don't know what to do next. But now it's the coefficients. What tells you that, Ava? Ratio. So, coefficients, because I'm going to copy my moles of C4H10 down here. And then my moles is going to convert to moles of the compound that I want. What is the compound that I want? H2O. Yes, H2O. I'm going to write that in blue. Water is blue. So let's go ahead and find these coefficients according to your reaction. What are your coefficients? Right. So 10 for H2O and 2 for C4H10. 10 and 2. Okay. All right, ratio is done. Let's move on to mass. So moving on to mass. What's up, Kalia? Do you round it? Oh, at the very end? Yes, round it. So at the very last part, we have mass. What units go down here? 1 mole. So not only mole of H2O, but it's always going to be 1 mole. And then up here, what is my molar mass of H2O? 18, right. So then go ahead and put this in your calculator. While you put this in the calculator, I'll go ahead and work on the next one.
We're not going to round or no?
We are going to round. The hundreds. Let's do the hundreds. What'd you get?
16.9.
16.9, exactly. 16.92, right? 1, okay. 91. So 16.91, and then I'll go ahead and set up the next one. All right, once you finish writing this down, you can go ahead and put this in your calculator. $4.71, got it. Okay, put it in your calculator. Make sure you're getting 4.71. Is it 4.71 or 2?
That would be 2.
2, okay. Got it. 4.72. So as you're looking at this, my eyes tend to follow a zigzag pattern whenever I'm checking y'all's work. So I'm always looking at my units and looking down and then up, down and to the right, and then up, and then that'll be your units. Okay, so when you put it on the calculator, you should get something like this. Make sure you get that. Look at my calculator, look at yours. Which one is the smaller number? 4.72. So this number is very important because this is going to be the product that we will theoretically find. We're never going to find 16.91 grams of H2O. We are going to find 4.72. So this is my theoretical yield. This is my theoretical yield. So that's the first point that can be made upon completion of this because it is the smallest number. You will never get this theoretically. And it's kind of like saying, like you bring in a bag of 100 graham crackers and you're like, guys, I have enough graham crackers to make 50 s'mores. But then nobody brought the marshmallows. So the person that says, oh, I can make 50 s'mores, we don't have enough. Okay, so along with saying that this small number will be your theoretical yield, we're going to look at our reactants. Okay, so our O2 and C4H10. This one, we're going to determine that the one that produced the smallest amount of product is going to be your limiting reactant. Okay, and then the one that produced too much product is going to be known as your excess reactant. Excess reactant. Okay, I'm going to write it in a different color because that is the main points of this. All right, so go ahead and go to the next problem. It looks daunting because, yes, you do have to do 2 T-charts, but read the question carefully. I structured it in a way that it shouldn't take too long. So number 2 says, when I react 12.34 grams of C4H10 with 10.9 grams of O2, how much grams of water will be found? Okay, so when we're looking at these two, I forgot to do this in the very beginning, but we're looking at these two. I'm going to go ahead and look at the reaction. And I see with these two, are these going to be my reactants or my products? Reactants. Okay, Okay, I just want to make that clear because some people will forget reactants, and then your product is on the right side. Okay? Yeah?
Will the test be mostly these?
Mm,
Sometimes, like,
not most of them. What's up?
sometimes the test isn't what we learned, or it's just like showed as like a harder.
Yeah, I try to make what you learn as close to the test as possible. Yeah.
So this won't be on the test?
Yes, this will be on the test. Okay, so go ahead and do number 2. Like, for example, as I was making this worksheet, I was looking at the test so that the verbiage would be similar. Okay, so I'm going to go ahead and put 12.34 grams of C4H10 up here. I'm going to put the other reactant, 10.9 grams of O2, right here. And then I already know that I'm going to set up my units. We're going to go from mole ratio I can't talk while writing. Mass ratio mass. Okay, so 1 goes with mole, and then 58 goes with C4H10. Okay. So then I'm going to set up my mole ratio. Okay, so it should be 10 and 2. And then I have 1 mole of H2O is going to be equal to 18 grams of H2O. Okay, and then all of this, I'll just copy and paste it all. Right over here, copy, paste, woohoo. Copy and paste. It is 19. Yes, so now whenever you put this in your calculator, you should get 19.15. I'll go ahead and pull up my camera, so it should look like this. 19.14, 83. Okay. All right. So, yes, we will. So, question, what is my theoretical yield? 4.72. What is my limiting reactant? 10.9 what? Grams of O2. Or you can just say O2. Okay. Yield. And then oxygen is going to be limiting reactant. And then C4H10 is going to be excess. Okay. So, excess reactant. Excess reactant. There we go. Okay, so we're going to go to our next topic, which is percent yield. So percent yield is going to use my theoretical yield right over here. Okay, so for right now, you can just do away with this number because this large number does not mean that's how much H2O I will have, because theoretically I'm producing more than I should because I don't have enough ingredients for it. So I'm going to say I won't get this number. I won't get this product. So I'm going to go to the other side to percent yield. For percent yield, we're going to write down the formula. Does anyone remember the formula? Percent yield. Is it theoretical over actual or actual over theoretical? Actual over theoretical. Actual yield over theoretical yield. And then you're going to multiply this by a number. What is that number? 100. And then whatever you get is going to be some sort of percentage. Okay? So that is percent yield. And if you notice, we already solved for one of these yields. So which one did we solve for using calculations? Theoretical. So remind yourself that this is from my calculations. Okay, otherwise known as my 3-step problems. 2 or 3-step, really. 2 or 3-step problems. And then my actual yield, where do I get my actual yield from? It's given, but what do I need to do in this class? I have to perform a it starts with an E? Yes, experiment. Found from doing experiment. Experiment, in this case, which is, like for example, making s'mores. Let's say I'm very clumsy with my s'mores, and I also don't guard them, so all the rats will get the graham crackers, everybody else will grab the marshmallows. I don't have enough for the amount of s'mores I will make, and I will be very imperfect. So the actual yield is most of the time less than your theoretical. So we're almost done, y'all. So stick with me. So let's go ahead and repeat this molar mass. It's the same reaction on this one, on this side, so you don't have to flip back and forth. 58, O2 is 32, CO2 is 44, and H2O is 18, okay? Okay, so actually we don't even need to calculate because we already did it. So number 3 says your lab partner told you that they got 3.96 grams of H2O in the lab. So what did they perform? An experiment. So if they did it in the lab, this is an experiment, and this is going to be what type of yield? Your actual yield. Your actual yield. Okay? Actual yield. Okay, so I'll just say 3.96 is actual. When I react for 12.34 grams of C4H10 with 10.9 grams of O2, didn't I already do this problem? Yeah, I already did it. What is the percent yield of the lab partner's product, which was 3.96? So you remind yourself that this is actual. Okay. So from here, we're going to find what is my theoretical. So remind me, what was my theoretical yield? 4.72. 4.72 grams of H2O. So look at question number 2. Question number 2, we already found it. So my question to y'all is, how much H2O will actually be produced again? Yes, 3.96. 3.96 grams was actually produced. So then from here, reminder, I got this question because I calculated it. From here, I got this because this was found experimentally. I'm going to plug it into my percent yield equation. Percent yield is equal to my actual, which is 3.96 divided by 4.72. Multiply it by 100. And that is your percent yield. All right, once you write that down, put it in your calculator. Let me know what you get. Okay, so I'm hearing 83.9. Put it in your calculator. Make sure you get that. I would round it to 1%. It really, for me, it doesn't matter, but it just depends on what your answer choices will ask of you. So I like to round it to 1 decimal places, but feel free to round it at least to 2. At the most 2 decimal places. Mm-hmm.
Did you get the passes to the box?
I think I did. Give me a pass. Yeah. All right, that's your answer. Okay, so just expect to be able to do this on your own. I will give you 1 problem yesterday. 1 problem tomorrow, and then that'll be it. All right, YouTube. Thanks for joining me.